The idea of rewriting it is 100% correct. But how do you rewrite it? Oh, that's fine. Which I don't even know where.
The bottom?
I would just do the x plus.
Well, it would be x to the negative 1/2 in the top, and then this x to the 1/2 plus 1, and then all that is to the negative 1.
Okay.
Oh, if you wrote this.
Or do you distribute the
Yeah,
square
distribute it
You could do, like, can I just flip this guy up?
Yes.
Yeah.
So you said it would be x to the negative 1/2, would you
Mhm.
agree?
Yeah.
Do I need to keep the symbol square root? No,
No.
we're okay. And then I'm gonna do the same thing here, x to the 1/2 plus 1, right? Okay. Is that,
Oh.
And then you're going to divide the pieces.
well, you don't
that's
really
it.
No, and
divide.
then that's your du over
So
here.
what's the derivative of this guy? Well, if I took the derivative of this, I'd have, what's the derivative of this? It's 1/2.
1/2
X to
x to the
negative
1/2.
1/2. And then what's the derivative of this?
plus 0.
0.
0.
Close. Well, x is close to that.
I see.
So plus 0, right?
Yes.
So I have so close, so close. What's wrong?
The 1/2.
So you know what I'm gonna do? I'm gonna stick a 1/2 in,
And then you just put a 2 on the outside.
and then I put a 2 on the outside.
I know how to do that.
You can just do that.
You
later.
can.
Yeah, you could do that.
As long as
You
it's
just-
just a number. You can't do it if it involves an x.
That's the
But if it's just a number, if I put a 1/3 in, I pull out a 3. Because I'm not changing it at all.
Put in a 3,
why?
take out
But how
a
does it just go to the top?
Just
Wouldn't it
put it
go
on
to the
the
bottom
top.
and the top?
Absolutely why we're doing it.
Alright. Wait, how do you what, you
You're
guys
basically
do it?
adding a 1 to it. That's all you're doing.
Oh,
You're changing it by 1.
so whatever makes equal 1.
Yeah, so whatever this becomes the du.
Oh.
Agreed?
Mhm.
And I need the du to be exact. So we got a problem. It's not quite because I'm missing the 1/2. So I'm just going to slap the 1/2 in, which changes everything. But when I multiply that 1/2 by 2, I'm really changing it by 1, which doesn't matter.
Yep.
So now, if I rewrite this, I think you would agree, I have 2 on the outside. This whole thing is now my du. This whole thing is now my u.
Mm-hmm.
Does that make sense?
Yes.
So what would its integral be? Well, the integral of du over u
Is ln
is
of u.
the natural log of the absolute value of u. Well, don't forget we had a 2.
Yeah.
And then what was u? It's whatever's in the bottom. So x to the 1/2 plus 1. And don't forget your plus c.
And then,
Yeah.
for doing that, it's the last one that we did before we integrated it, right?
The last
Like the last form, so we would go back to the first one for the inside of, you get what I mean?
Yeah, you mean this to the 1/2 instead of square root? No. Yeah, good tell me, because I have no clue.
It's like, really much about, like, this
Yeah.
is that.
Correct.
Because
Yes.
that was the last
Because
one
that's
we
my
did,
u.
and we wouldn't go back.
Correct,
right?
yes, yeah. Yeah. Yes.
So when you take the derivative of u, then you just cancel the top with that? And then you had 1 over
The
x.
integral of the derivative brings you back to the original.
Right.
And would the original have du in it? No,
No.
right?
Right.
No. Okay, let's do another. Thank you. May I have another?
It says harder because it's not true.
To add anything with integration.
Say it again, hon.
I'm just going through like the 1/2 and the 2.
Oh, okay. In your brain, you're kind of going through it?
Do we have that worksheet?
No. I'm going to give it to you.
I finished the worksheet.
Yeah, that's what everybody was saying, that they felt really comfortable with
Mm-hmm.
it.
That I feel comfortable with, and now back to square one. I feel.
You will be, because this is just a little addition to what we've learned.
Makes me want to try just a teeny bit.
No.
Because it makes sense. It's just I'm like completely blindsided by it.
You wouldn't be able to simplify because the 2 is attached to the x on the bottom.
Right.
You can still split it, you put that
Yeah.
denominator.
Yeah, you put it x plus 2.
Put that on.
Break it all
Would you want to split it down?
I don't think that would help.
These things? No.
So, this one is new. This is something we haven't done yet.
Do you factor the top?
I I'd love to be able to factor the top. See, this is what I love about these types of problems, because everything you do, you're kind of thinking, should I do this? Nope. It reminds me of you're going through a maze. You hit the wall, you go, shoot, come back, start here. Oh, darn, you know? You see what I'm saying?
So the trick identity.
It's one of them, here, we're hitting the wall, but then we're thinking, okay, so there's another route. There must be. There's always another route, but you have to figure out what route we're going to try to attempt.
It's like the trick identity.
It's kind of like the trig identity. Right, it's kind of like, it's like a puzzle. So now I'm looking at this thing. So far what I've taught you is, can I just take a basic integral be done? No, because it's a fraction, right? So if you were making a flow chart, you would say, is it a fraction, yes or no? If it's not, then just take a derivative, an integral. If it is, then let's figure out what route should we go. Yes?
Is there like a reverse quotient rule or something we can use?
Not really a reverse quotient rule, but I have shown, what have we learned so far in this class this year? The top topics. What have we done? Does anybody remember? We did derivatives.
Unit circle.
We did a little unit circle, like talk
Trig
about
Trig.
identities, right?
Polynomials and modulus.
Polynomials included what?
Synthetic division and logarithm.
Oh.
And setting up the charts and the discriminant.
What's that?
We use the chart and the discriminant.
Why do these
We
things
did.
come together?
Yeah.
Right. So, okay, so let's think again. Everything has its purpose. And this particular class is why a lot of people like this class, is because you start to see why you start to learn the things you learn in math. Because it kind of pulls it together minimally. As you get higher in the math, you're like, oh, okay. So anytime I have an exponent that's larger on top, then I can attempt to factor it out. We would love to be able to unfoil it. In the perfect world, I'm unfoiling it, I'm canceling out the denominator, and I'm integrating. I can't do that here. I would love to. Like, you know what I'm saying? Like if it was x squared minus 4 over x plus 2. Then you would go, oh, Miss K, that's x plus 2, x minus 2. Let's get rid of the x plus 2 and integrate. Do you see what I'm saying?
Yeah.
So, not so perfect world, but we have learned a technique that kind of creates this to be a little smaller. It's a form of factoring. You learn how to do long division. You learn how to use synthetic division simply to help you through the process of sorry, talking and erasing, can't do it. So simply to do this type of problem, where you actually are going to start to break it down a little bit. So let's see what happens. I'm going to use long division so you can see the technique that goes into this. We have x plus 2. Now, on an AICE exam, am I going to come across a problem that looks like this? Probably not. Maybe. But I need to get an introduction to you so you have an idea. Okay? So you don't come to a place where you go, oh shoot, the denominator's exponent's so much smaller, what do I do? Oh, maybe I could use long division.
We could synthetic.
We could synthetic as well, but I just want to do it this way just to show. Okay, so if I'm going like this, I'm saying x goes in here. It goes in x times. And where does that number go above? Well, it goes above here, right? So I'm going to multiply it out. I have x squared plus 2x. Subtract it down. Everybody good with the long division at this point? Subtract it down. That's gone. Negative x minus 2x would be minus 10x. And then bring down 3. Everybody okay? Next thing, right? So minus 10. I think you guys would all agree. Yeah? Multiply it out. So negative 10x minus 20, right? Just we're multiplying. So we're going to subtract it out. The 10x's go away, and I end up with 23. Very nice. and so truly, what's left? Do you guys agree that that is really x minus 10 plus 23 over x plus 2? Do you guys agree?
Yes.
Yeah.
Yes.
So you just replace that in front of that? Yeah.
Because they mean the same thing.
Right.
So this divided into this is that plus the remainder.
It's just like saying 4 divided by 2 is 2.
It's 2.
Right.
Right. So have I lost anybody so far? Now, can I integrate x?
Yes.
Right?
Mm-hmm.
Can I integrate negative 10?
Yes.
Right. So I'm going to actually integrate each of these pieces separately, just because it works out easier to look at. Okay?
Right, actually, the 23 over x plus 2, that's just because it's.
The remainder.
Yeah, the remainder. In the past, we would put the big R and then put to 23. But really, what it means is this over your divisor.
Okay.
Okay?
And if it was negative, you put a minus.
Uh-huh. Right.
Fully divided by 3.
Yeah. It doesn't go evenly. Which it would have. I mean, if it did, we would have unfoiled it and taken care of business. Okay. So what is the integral of x? Well, it's x squared over 2.
Uh-huh.
Easy enough. What's the integral of 10?
10x.
Minus 10x.
Mm-hmm.
And then, how do we handle this? Well, the 23. It's just going to go for the ride. Okay, 23 is in my way.
ln.
I'm going to put a 1 there and put the 23 out here so I can see it.
Mhm.
Tell me why ln.
Because you have something in the denominator, which means that, like, you have an asymptote going on, which means that you can't have, the denominator can't be 0, so, and the ln fixes that.
Oh, I like the way you think, but I never think of it that way. I just think, ooh, if I took a derivative of this, is it this?
Yeah.
You're far more complex than I am. That's impressive. So I go, derivative of this, yeah, check. I have the natural log. And so I have a d over u situation. So 23 went for the ride, the natural log. What goes inside that thing? The absolute value of x plus 2
Plus C.
plus c. You have the smiley face because you finalized the problem. Once again, something that looked kind of difficult has now become pretty easy through one of the methods that you've learned so far in this class. Yes?
Could they have, like, sines and cosines and e to the x for that type of problem where we
Okay.
divide it?
Will you divide it? No.
It's
No.
always going to be just a regular polynomial.
Right. Let me give you a challenge. I'm sorry. Don't say it out loud. Don't yell the answer. Let everybody have the same fun. Did you just ask me if they were going to put e to the x in the problem?
Yeah.
I did. Just because I think it's fun.
It only does itself.
Don't yell.
Well, how many times does e to the x go into e to the x?
Do you have to?
Yes, you see it.
Interesting.
It's very,
It's the
very.
same thing.
I see a thing.
Same thing.
Think about the day.
About-
Yeah, you'll see the day.
I see a thing.
The 1 over 2.
Do you see a thing?
See it there.
See a thing.
I see more letters than numbers. And frankly,
I see a
We
thing.
have a sentence for
The
equation.
fact that I get that makes me uncomfortable.
It makes me really happy. The fact that I put that up there and some of you are like, oh yes, and some of you are still going, maybe? Maybe?
You could just divide the individual pieces.
Do we have to divide? No.
No.
So remember flow chart. Fraction, yes or no? Yes, darn it. Okay, here I am at fraction. First thing I should look at. If I took the derivative of the denominator, is it in the numerator?
Yes.
It is. What's the derivative of the denominator?
Yes.
E to the x. Well, holy Hannah, I have du over u,
Mm-hmm.
right? Life is good. Because remember, my flow chart told me, if I can do that, I'm done, life is good. If not, then I have some maybe other things that I have to do. Maybe rewrite it, like we did in that one. Maybe long division, like we did in that one. Okay? So what is the actual answer to this?
ln e to the x point plus 1. Yep. Plus.
Done.
So if it is the d over d, it's
Just that.
ln and then whatever's in the denominator.
That's it,
plus
every
c.
time. Now, the only time that the answer might vary a bit is like if there's a 2 up top that shouldn't be there. Like I took the derivative here, it's e to the x, darn it, I have a 2 that doesn't belong. So I would take that 2, say you're a pain in my butt, bring it to the front, and then just put it in the front.
Okay.
Or if there was a 2 down here,
Mm-hmm.
like a 2 here, what's the derivative of this then? Well, it's 2 e to the x.
Mhm.
We got a problem because we're so close. I would stick a 2 in there and then do what?
Pull out its
Pull out a
reciprocal.
1/2. If I'm putting the 2 in there and pulling out its opposite, if the 2 is already there and I don't want it there, I can pull it out. Did that make sense what I just said?
Mm-hmm.
Okay.
Miss K?
Yeah.
So then you wouldn't have it ln of the absolute value of 2e to the x plus 1.
Wait, what?
Like you can't have that.
Yeah, you can. Yeah, you can.
Yeah.
Yeah.
And then whatever the coefficient is of the e to the x in the numerator is going to go in front of the ln.
Right, if it's a nuisance, if it doesn't belong.
Right.
So what was your question? I heard you kind of saying you had why? I just put 2's in there for an example.
Oh, okay.
And the example was, if the 2 was here originally, it's a pain in my butt because e to the derivative of this is just e to the x. So 2 becomes, I don't want it there, so I'm just going to pull it to the front.
Okay.
And I'm just going to go for the ride with it, right? Now, the other scenario is that originally there's a 2 here, or a 3, or whatever. And then I go, ooh, what's the derivative of this? Well, it's 2e to the x.
Yeah.
So the problem is I need a 2 here. So I stick a 2 in there, which means I'm changing things, which means I have to pull out its reciprocal, which is 1/2.
Okay.
Does that make sense to all? Okay. Everybody good? I got another challenge. Somewhere. All right. I don't know if I've done this one yet.
We'll see. No, not yet.
Does he have?
Yeah.
If you did the thing where you had to pull out the 1/2, would you put anything in front of the ln or no? Since it. Like
You would put the 1/2 in front of the other. Yeah.
Okay.
Would it be like 1/2 ln 2ex?
Yeah. it's
Okay, you want to know? Yeah. Yes. Yes.
Okay.
Because the original would have had a 2 in there.
Okay.
So I would have put a 2. Yes. Yes.
Yeah.
Look at it for 2 seconds.
So wouldn't it just be ln of the absolute value of x ln of x plus e?
What the heck?
Wait, is that ln of x?
That looks like what
It's
would be
XL and X. Yeah.
So,
So,
should there be?
that's the thing.
Why are there not the
Only when
things?
the answer happens. It's kind of like. Let me liken it to something we're familiar with. If I tell you x squared equals 4 and I tell you to solve for x, right? You would tell me, x equals plus or minus 2. Because we know when we take the square root when solving, we have a plus or minus, right? So, but if I just told you I have x squared, you're not telling me I have plus and minus x squared. It's only when I do something to it. So when I integrate it, I've done something to it. Now I have to take into account that it has to be positive always. Same idea. This one's a really good problem.
I don't know if I'm right.
Did you pull out the ln?
You never can pull out okay, that's another good thing. I pull out a 2, I pull out a 1/2, I pull out a 3. Do you see what I'm saying? I'm pulling out numbers. I'm pulling out absolute, concrete numbers. I cannot pull to the front of that anything that has to do with x. X has to stay in part of the problem.
You can substitute ln of x for something though, right?
Can you have ln of ln?
The answer could be ln of ln of something, yeah.
Substitute one for
Quite possible.
No.
Well, the derivative of ln of x is 1 over x.
Yeah. So can we just do
The
that?
derivative,
ln of x,
What's that?
1 over x.
What'd you say?
the derivative of ln of x over 1 over x.
It is.
So 1 over x squared, and then you integrate that.
No, but it's 1 over x.
Wait, what's 1 over x?
Yeah, 1 over
x, which is x over x, which is
Which is
1.
what?
Well, 1 over x times 1 over ln of x, which
No,
is
say it again.
The derivative of ln of x is equal to 1 over x.
right.
So x times
1 over x.
Right.
Which is x over x, which is 1.
cancels out, so it's 1 over 1, so we have 1.
So we're
But
in the integral of 1
the
is
integral
x.
Huh?
Your integral is x.
Yeah.
So
No, yeah, it's fine.
Yeah.
The thing that we have to take an integral of is 1,
Yeah.
right?
Okay,
Yeah.
let's go to my little flow chart. Is it a fraction?
Yes.
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 So I'm going in that direction. First thing I think of is, do I have a du over u situation?
No.
Well, the problem is, right now, I don't really have a du over u situation. We had a problem just a few minutes ago where we rewrote something. And we made it kind of a du over u situation, just by simply rewriting it, not changing it. Let's go back to what I'm talking about. 1 over x times the ln of x, right? How can that be rewritten?
X times 1 over.
Oh,
No.
okay.
No. X to the negative, okay, let's write that first. So, let me show the slow motion here. x to the negative 1 over ln of x. Yeah? So far so good?
Mm-hmm.
I don't like x to the negative 1. What's that really called?
1 over.
Uh-huh. So let's rewrite it
Yeah.
again. So
Okay.
1 over x over the ln of x. Noah, what did you tell me?
The derivative of ln of x is 1 over x.
So the derivative of this is this.
Yeah.
So that's du over u. Well, that's crazy.
So
We have a du over u situation.
We just move the x to the top.
Yeah, you can. Right.
So
Yes.
it's,
Why would you take the derivative of ln of x? Because you have the derivative and you're going to integrate it. So wouldn't you be taking the double derivative?
Well, remember, anything that's du over u, by definition, is the natural log of the absolute value of u plus c. That's the definition of it. So your ultimate goal, while doing this crossword puzzle, or whatever we're calling it, your ultimate goal is to try to get it to look like a du over u situation.
And so it's okay to take the derivative of that, even though ultimately we want to integrate it.
You have to get it to look
Right.
like that.
Yeah.
we're
You
using
have-
a derivative test to make sure that the top is the derivative.
Right.
We're not actually.
And if it's not, then we go to plan B, and if it's not, we go to plan C, and if it's not, then we go to whatever, and then we cry.
Yeah.
It's like 5 or 6 plans before we
I
cry.
made it crying before.
No, you're not gonna cry.
Not until you
Not
get,
until you hit plan
get
5.
out of the
Not until you get
test.
like
To
ln of
plan
ln.
E. You have
Okay.
to get plan E before
So,
you cry.
would the answer on that be like ln of the absolute value of ln of x?
Yeah.
That-
Let's see. Gross.
That is weird.
ln of ln.
That.
Don't forget.
I
Don't
don't
forget
like
the
that.
C. Don't forget to cry.
Don't forget the C. Oh, yes, that's right. If you forget
What's
the C.
That makes so much. Oh,
It
we
does.
Can, that's
We
a
can
really
utilize
good way to
that.
remember
Add
it.
the cry.
Don't forget.
Add the cry, because you guys,
It's
Miss Kay?
positive reinforcement.
K is
If we
gonna make you cry.
And you had ln out front because the numerator 1 over x is ln of x. So it's ln of the denominator ln of x.
I'm suing.
Yeah. All right. Have I blown your mind a little bit?
Yes.
A little bit,
Okay.
yeah.
I think the biggest biggest mind blow was the derivative or the synthetic division, the division part.
I love that.
I was like polynomials and modulus. You guys, what's a part of polynomials? Long division. It's division. How do you do this?
How about this one? And then I'm gonna move on.
I don't know if I'm ready to move on. I kind of like this.
We could use synthetic division.
Is
Or-
it bigger on top?
Oh, right. So long division.
More
You would only
rules.
divide
If it's bigger.
if your top is bigger. Step 1, is it a fraction?
Yes.
Mm-hmm.
Step 2, is it a du over u situation? I don't know, let's look. What's the derivative of this? I'll write it down.
2x.
2x. Derivative of this?
1. Or,
Two.
no, 2. Yeah.
2. Derivative of this?
Nothing.
Zero.
It is.
How?
You factor out to 2.
We got
Yeah.
something wrong. We have a 2 too many. Like this would be 2 times x plus 1, right?
Mm-hmm.
You moved it to the front.
Shove a 2 up there and put a 1/2 outside.
That's right. Shove a 2 up there, pull a 1/2 out front. Now do you have a du over u situation?
Yeah.
Yes, you do. So what's the answer? It's 1/2 goes for the ride now, right?
ln
The natural log of absolute value of,
x squared
Mm-hmm.
right?
plus c.
Do you see how the flow chart works? We're going to build to the flow chart. Yes.
So you don't need to incorporate x plus 1 into the final answer, like
No,
in front of...
The
Yeah, right.
definition,
Right.
the integral of du over u is the natural log of u plus
We
c.
should actually make the giant like flow chart.
We really should.
poster or whatever.
I think you might end up doing
Full
that.
chart poster. that's
Yes.
So when you're doing a du over u thing, you always take the derivative of that?
You want to see if the derivative is there. Because that's kind of our flow chart thought. Fraction, yes or no. If it
You don't take
is,
an integral though on the bottom?
after you're done, you take that's the integral. This actually is taking its integral.
We want it to get it to say du over u.
If we could possibly do it, we wanted to do it.
And what if we can't do that?
Well, we have like long
If the
division.
denominator
Or-
is bigger,
yeah.
then you do that derivative check. If the
Right.
numerator is bigger, you can probably divide.
Long divide. We have a lot of like we have time. We have time to work on different scenarios. The hard part about teaching this is that there's like, what scenario we're going to use. I mean, we have to have our tools.
Test, if it's even gonna be on the test.
It will.
Probably.
In this level it will, but I mean, you just kind of have to figure out. I can't guarantee every one of them will be on there. It'll probably be one of the many scenarios that we've accomplished.
It'll probably be like a part 3 out of one question.
So, you know, the idea is how can I prepare you best for it? So the flowchart, I love that. You know, that might be like our homework problem for the night is to go home and try to start to create what we consider that little flowchart, just like you're doing.
Yeah.
Exactly. That way, when we come back together tomorrow, we can see if we can add to it or help each other create. Oh, bring it in. And then tomorrow we'll put all of them together with what else I teach you. It won't be finalized tomorrow, I guarantee you that.
When did you say the test was going to be?
Next week, so I'm not. Yeah. Okay. Okay, so I'm just going to introduce. What time?
We've got 3 minutes.
When is it late?
10:09 is when we get out. 4 minutes.
Time goes by.
Wait till tomorrow. Darn it all.
Throw up one of these.
I wanted to do. I'm so excited to teach you the next lesson.
Miss Tay,
But this stuff had to be done. Yes.
is there anything that you expect us to do tonight?
Yeah. What do I expect you to do tonight? Try to do a flow chart. Try to hit your brain. Well, you're going to create one, and then we're going to come together and make sure we have everything we need.
And the flow chart's like step 1, see if it's a fraction.
Right.
Step 2, see if you can make it du over u, and then from that you can use long division or synthetic
What
division.
is this stuff called?
Just integration.
Integration.
So that's hard. That's the hard part. Okay, one more before you have to leave. I don't know. Oh, that's a stupid one. We won't do that
I
right
just
now.
want to sitting at the table tomorrow morning talking about my flow chart for integration.
I like it. People are going to wonder what's wrong with you.
I made an
Is that a
integration.
D? Is that 2 U?
20.
Oh, 20. Oh.
See, but I love math, so I really don't care. Yeah. Do we use chain rule? Yeah, we can use chain rule. Think about it.
20?
20 x
That's a big number.
squared
I'm gonna
plus
sit here
1
and
to
multiply it all
19,
out.
and then 2x.
So we want to try to get it to say du over u and test to see if you have that situation.
No, you don't do that.
Yeah. So it'd be 20 times x squared plus 1 to the 19th times 2x,
Which is gross.
which is, yeah.
I look 40.
No, you don't use loading high. We're only taking the derivative of the bottom.
Yeah.
Alright,
So
let's
you don't
see.
use
Can we
loading
get the
high.
bottom to be the top?
It would be 20x squared plus 1 to the 19th. 2x.
And we want to try to get that in the top and then pull
And then
out
you times
anything
it
that
by
we
2.
place in there, the reciprocal. So that way we
What
don't
would
change
you do with
anything.
that x squared
No,
plus 1
because-
to the 19th? Me too, Nick.
Okay, it's gotta mean something because there's a 20 there and a 20 there.
Yeah.
And the x when it comes down becomes the coefficient when you do the derivative.
Coincidence.
Oh, that's a coincidence?
How would you approach this problem?
With a lot of tears.
That would be.
You just
Now 2x.
How do you do that problem?
Shove it up to the top.
Shove it up to the top.
Yeah.
What do you get when you shove it up to the top?
x to the negative 2.
Okay, so far so good?
Yeah.
Okay. So then you integrate.
Mm-hmm.
How would you approach this problem?
Very easily.
Shoving x squared plus 1 to the 20th up to the top.
Oh, we are. Okay, let's do it then. So if I shove it up to the top, what do I have?
20x.
Because do I have a du over u situation?
No.
No.
Absolutely not. I got issues because I have
Yeah.
the 20th
I
power,
was
right?
checking.
So I have x squared plus 1 to the negative 20th, right?
Mm-hmm.
And then I'm going to put the 20x right beside it, right?
Mm-hmm.
And then we reverse chain rule.
Easy substitution.
Or use
It's a,
some-
it's a
yeah.
form of u substitution. What's enclosed?
The x squared plus 1.
Times 20.
So if this is called my u, oh,
Or you can use the easy method. take it as if it's an x
What
to
is
a
it?
power of.
It's an interval. Yeah, yeah,
We use that for integrals, right?
yeah. We'll finish tomorrow.
Don't worry about it.